CROSSING is a joint effort of scientists from quantum physics, cryptography, system security, and software engineering, who collaborate in 3 interconnected project areas. In Project S2, CROSSING is doing research on attestation protocols. Embedded and mobile systems are increasingly integrated into many spheres of everyday life. Smart devices build up complex networks in which they communicate with each other, as well as with the outside world, mainly by using wireless interfaces. The problem with this is that these networks consist of security and safety-critical applications, which lack the necessary resources to defend themselves against attacks. For instance, this can be seen in automotive networks. In cars of the future, embedded devices exchange safety-critical and privacy-sensitive information used by driver assistance and autonomous driving systems. Cars can be equipped with self-driving and automatic braking features and are able to identify objects, persons, and other vehicles in front of them. If the system responsible for self-driving is compromised, in the worst case, the car would jeopardize people's lives. It is obvious that automated systems make an attractive target for attackers and increase the need for modern technologies that validate and verify the integrity of their software state against malicious code. Therefore, CROSSING's research area S2 is doing research on attestation schemes to detect compromised components of complex systems. Remote attestation allows an authorized party to detect changes to a user's system. It works as an interactive protocol between 2 parties, a verifier and a prover. The verifier is able to determine whether the prover is in a trustworthy state or not. In secure attestation protocols, a remote entity called the verifier sends a challenge to the entity to be attested, called the prover. Attestation code on the prover's device then measures the software state on the device and sends a response back to the verifier. The verifier in turn checks the report and decides whether to accept or reject it, depending on whether or not the running software is in an unaltered state. This project will design and develop novel attestation schemes that allow the validation and verification of software integrity and trustworthiness of remote devices. Major goals of S2 are to minimize the security hardware needed for attestation, to provide secure attestation in the strong adversary model, and scaling to large networks. We are also developing defense solutions against runtime attacks. To learn more about attestation protocols, please visit our website.